In this movie, I'm going to talk about creating output from EnRoute. So the first thing I have to do is I have to create some toolpaths. So I'm going to type in some text here. Okay, so now I've got geometry created, and I need to create toolpaths associated with that. And the most common is a routing offset. So I'm going to create a routing offset, and I do that by choosing a tool. So I double click on the tool here and give it a depth, and of course I can define other parameters associated with it, number of passes and feeds and speeds and all that sort of thing, but I'll just use defaults in this case. When I click OK, the toolpaths are created. You can see where the start point is. I didn't define an entry or exit for this, so I just have a start point that shows up. And so let's assume that this is the right design for what I want to create. And so when I go to create the output, I choose tool order and strategy order, all of that. In this case, obviously, I just have one strategy type and one tool type. So I can click create output and type the name of the output file. And so what happens at that point, what happens is that EnRoute creates output in the form of what's called a P-code file or a PCD extension file, and that is a binary file that is in a particular format that is the same every time. So the PCD file gets created, it's the same file every time, and then EnRoute notifies the driver. It notifies another small application called the PT to activate the driver, and the PT then uses the selected driver to translate the PCD file into an output file that's appropriate for the machine that you have selected. So I have a particular machine selected, and I've defined things such as a tool changer where I have the tools in it that I might use, and then other parameters associated with the driver, the position of the home, the whether or not I have a drill bank, min and max driver speeds. There's units, what unit the driver or the machine is expecting to see, communication parameters if I want to output directly to the machine, and then other parameters associated with some sort of more detailed tolerances and minimums and maximums, that sort of thing. So once I have all of that set, choose a driver, put the tools in the tool changer, and I'm ready to create output. So once I have output created, then I can use another application called Backplot to view the output, and I already have Backplot running here, so I can call up the file that I just created, and so then Backplot shows me an actual plot of, in this case, the G codes that are used to create that output file. Oops, I cancel out of that, and I'm going to go to the perspective view, and so here you see a view of a combination of lines and arcs. Lines are in blue, arcs are in red, of the output file that was created from those toolpaths in EnRoute. And so this has already been translated by the driver into the appropriate output format, in this case a particular form of G-code that was created from the P-code file. Now, one of the nice things about Backplot is it can also look at the P-codes, and so if I hit Control Shift F11, then what that does is it toggles on the keeping of the P-code file. So the P-code file typically is created, and then the driver then, or the PT, will delete the P-code file after it's been used. I can toggle that off so that we save the P-code file, because that becomes an important way to troubleshoot or debug a driver, is to have the P-code file to look at. So then once I create the output, which I haven't done yet, so I'll create the output, I'll call it toolpath 2, Okay, so now that I've created that output, I can get into Backplot here and I can open. So now you see the toolpath 1 that I created. Now toolpath 2, I have both the CNC, that's the output file, and the PCD, which is the P-code file. And so I can actually open the P-code file, and of course the plot of it, as expected, I would expect it to look basically the same. In this case, there's one change here. There, that will show me the z-axis going in the other direction. And now when I look at this, these are a text representation of the binary P codes. So job params, messages, there's a start job, a roll feed actually gives me some information about in this case the thickness of the plate. Another message. The messages are sort of the way that we have to send some specific information that was not anticipated with the original specification of the P code. So in this case, version, the name of the app, the location of the file, all that sort of thing come out as messages. Setting the machine plane, the tool change, feed rate, plunge rate, the spindle speed, and then I finally get to a start contour, and then I have a series of arcs, and draw XYZ is a line segment, draw arc is obviously an arc segment, and so I have a combination of those that define the output file. So this is the information that comes out of en route that is almost the same every time. It's certainly the same format. Some of the messages that get created may or may not get created depending on the driver that I'm using, and depending on how the driver configuration file, which is called the CNF file, depending on how it is set up. And so this is a really handy way, because I can look at the PCD file, and then I can also look at the output file, and you can see in this case that the positive X or the positive Z changes from the P-code file to the output file. So that has to do with that driver translating it in a slightly different way as to which way is a positive direction in the Z-axis. But this is the output file that was created by the driver directly from the P-code file. So this is again a really handy way to see what's going on, and to make sure that things that are happening in the P-code file are translated correctly into the output file. And so Backplot provides a way to look at both of those. So if I get back into en route, it's a question of defining parameters associated with the driver. All of these parameters go into what's called the CNF file, and if I'll open an editor here, and I can open a CNF file so we can look at it real quick. I go into the NDrivers folder, and I'll look at it for the machine that I'm using, which is the Multicam GC file. Here we go. Okay, so this is what the CNF file looks like. It is in the format of an INI file. It's an older format. It's a very simple text file, but it has sort of sections that are defined. and then parameters under each of those. It just takes the form of parameter name and value. Parameter name and value. So this is an INI file. This is read and written by en route, and then also read by the PT, or read by the driver as part of the translation process. So these are things like the drill bank and the tool changer are set up in the CNF file. So in this case here it's showing that my turret has 8 tools in it. Tool number 1 is a 1/4 inch end mill. Tool number 5 is a 90-degree conic. These are the names that come from en route, from the tool library in en route, and then are set up in the CNF file. This shows a drill bank. I don't have a drill bank turned on in the driver at the moment, so that's not being used. But the CNF file is another way to see what the parameters are, what the driver is being told in terms of key parameters associated with it. So a quick overview here: create the tool paths, go to output, which activates, which utilizes a driver. I say to file. I'll give it a name here. When I say to file, the P-code file is created, the PT is called, which activates the driver, which does the translation, and then we end up with the CNC file, or the output file. The extension is defined in the CNF. The actual output file, as well as the P-code file, which is typically deleted. Remember, Control Shift F11 is how I toggled that, and that toggles whether or not the PCD file gets deleted automatically, and then I have the output file from the driver. So hopefully that helps kind of illustrate the process, and the next step really is to understand how the driver is written and compiled, and so I'll create a video that explains that process also.